All right, let's get started. The quizzes are making their way around. I've entered the scores into the grade book. So you can go online at any time and see what's your weighted average in the course right now. And as I've already mentioned previously, I've turned on the feature that allows me to drop the 2 lowest homework scores from calculating your grade. So right now it's got that included in your homework average, and then the way that final column is set up is it knows the relative value of quizzes versus exams versus homework assignments and so on. Of course, we still have another midterm exam, we still got the final exam and the project, so there's still a lot you can do to improve your grade if that's what needs to happen. But I wanted to make a point that I think is important, and that is none of us can be expected to understand 100% of what we hear. And so you're not going to understand 100% of what you read in the book. Maybe there are certain problems that you didn't really understand. Maybe you went through the process, but in the end you're not sure exactly what's going on. And so it's natural that maybe you're only going to figure out, let's just be generous and say 95% of what you hear and what you see and what you do. But then if you're only attending class 75% of the time, you're only going to understand 95% of 75%. And then that's where it's really a problem. And so, I mean, you're all here, so I'm preaching to the choir, so to speak. You're here, and so you know attendance is important. But I'd encourage you to just make a commitment to yourself that you're going to watch every lecture. And even better, you're going to be in class for every lecture, that you're actually going to do the reading assignments, solve the homework assignments, and understand each problem, not just trying to get a certain number that you know is the right answer, but following the process and really connecting with the principles there. And then I have lots of office hours that are generally pretty quiet, and so I'd welcome you to stop by and see me for help anytime you've got questions. I'll do my best to help you out, but if things are headed in the wrong direction, if you're headed towards a grade that you're not going to be satisfied with, I think now is probably the last opportunity for you to ask yourself, what can I do differently to change how things are going? Because your grade is, there's inputs and there are outputs. And the output is your grade, and the inputs are the factors like if you're reading the assignments, if you're doing the homework assignments and understanding them, if you're attending and participating in every lecture, and so on. All right, so I didn't want to preach too much, but I have noticed that there seems to be a correlation between people who do well on the exams and the quizzes and those who are always here and always aggressively active in the in-class exercises. I got a couple of good questions about the project. Your classmates are thinking about that and wondering and asking me questions, and I got one related to cost of living adjustment. Now, cost of living adjustment is a phrase that's often used when describing how your income is likely to increase over time. Employers know that inflation is occurring out there. Employers know that if they just kept paying you the same wage forever, that gradually you'd be able to afford less and less things because the prices are going up. And so to match the increase in expenses, most employers offer cost of living adjustments. Now the question I got was, are those two factors the same? And in a lot of cases they are. Occasionally there will be an employer who is more generous in their cost of living adjustment than the base rate of inflation. But more or less, the two are about the same. And you can do a Google search for any of these phrases, cost of living adjustment or inflation rate. If you do a Google search, I had it linked to a Google search, but I'm not going to do that because you can do the same thing. You don't need to watch me Google. You'll find a couple of really good resources out there. There's the Bureau of Labor and Statistics. There's the Social Security Administration. And both of them are really focused on gauging how prices change in the economy and also tying inflation to cost of living adjustments for things like Social Security. The elderly who are drawing a retirement check have to have that check go up over time. And so there are tables out there that will show you what has been the cost of living adjustment for each of the years going back a lot of decades. And so you can kind of get a sense for historically what that average cost of living adjustment has been. And then as you project into the future, you can make some assumptions about how your salary is likely to change. And remember, it's not just changing because of the cost of living adjustment. It's also changing as you get more experienced and as you get promoted, taking on more responsibilities and that sort of thing. All right, so I thought that was an interesting question, and I wanted to share some of those details with you. The other question I thought is worth addressing is, how specific do you need to get in your estimation of the expenses? And so let me begin by showing you what wouldn't be enough. Like, I'd consider it not okay if your estimate was looking like this, rent 500, utilities 100, food 300, insurance 150. Because I'd see that and immediately think, oh, they just pulled those numbers out of thin air. Instead, if you're going to make an estimate for what your rent is going to be, find a listing, an actual listing of a place that you'd want to live in. So find some 2-bedroom, 2-bathroom apartment in an area that you're glad to live in, and it has the features that you need in living space. And then you can just do a screenshot or a printout of the first page that shows that listing and tuck it into the appendix. So then in the write-up you say, I base my assumption of the rent on an actual listing that I found out there in the rental market. And you're not just maybe living in a student-style apartment after you've got an income, Utilities 100. Well, utilities is a lot of things. It's sewer, water, electric, cable, trash. So go one level deeper than that and have data to back it up, actual underlying data other than just, oh, that seems like about right. So what about food? Well, again, I'm suspicious of just some abstract number that's been plucked from the sky, and especially in the case of food, because most people don't buy food once a month unless you live in a really remote area. Like if you're in Alaska and it takes you 5 hours to drive to Costco, then maybe you shop once a month. But most of us are shopping more frequently than that, so we don't think in terms of monthly food budget so much as maybe a weekly food budget. So my suggestion would be, in the case of things that you buy on more than a weekly basis, like fuel, more frequently than monthly, like fuel or food, then actually go one layer deep, one additional layer deep. So instead of just saying food, you actually look at what are the things in your cart on a weekly basis. So, this is like a second layer estimate. You could even go to a third layer estimate and say, like, which brands, how many servings. Maybe you're just a real bread lover and you're going to be having a loaf of bread every day. So, which bread and how many servings. So that would be three details deep. But the point is, try and provide as much realistic data as you can. Okay, so any questions on the project? All right. Today we are going to be doing something called incremental analysis. The word incremental means the difference between two things. So the increment between 5 and 7 is 2. It just means subtract the two numbers and find the difference. So the incremental cash flow, if we have a cash flow diagram, the incremental cash flow is looking at the differences between two things. And that's one of the core principles of economic analysis, is when you're comparing alternatives, you can ignore all the things that are the same. In fact, if you're comparing anything, if you're comparing cars, if you're comparing people, don't focus on the things that are in common. If you're having to choose between one thing or the other, you focus on the ways that there are differences. So what you do for an incremental cash flow is you would subtract the larger, from the larger cash flow, you'd subtract the smaller. Now here's just an illustration of two alternatives. Let's say that we have option B and option A, and each one of them has a known original first cost that we have to pay to obtain that option. And then you can see that each of them has an annual operating expense and then some salvage value that you get for retiring the equipment at the end of the useful life. So the increment is just the larger minus the smaller. And so the incremental cost for option B is $20,000. Now its actual cost, its absolute cost is $60,000, but the difference, that additional money you have to spend to get B instead of A, is $20,000. So in incremental analysis, the question you're asking yourself is, should I pay extra for the more expensive option? You know, is it justified to spend that extra $20,000? And so if you compare B to A, why do you suppose B costs more? What's its marketing advantage? You know, if someone, you don't even know what this is, but if they were going to do a marketing campaign for product B, what would they be bragging about? What's that? Less expensive to operate. Yeah, so look at the operating costs, $19,000 versus $25,000. So think about maybe this is some sort of an industrial truck that has a more fuel-efficient engine. So they're charging more because it has a more fuel-efficient engine, but then because of its increased fuel efficiency, it costs less to operate. Now, it would depend on how many years this thing is operational to answer the question, is it worth spending the extra $20,000 to save $6,000 a year? If it's only going to last for 1 or 2 or 3 years, then the answer is obviously no, because you're not going to recoup your investment. But if this thing's going to last for 10 or 15 years, then it's quite possible that when you discount that future savings, it's still more valuable than the added cost was. So incremental analysis follows this pattern. It's a comparison of the differences between the two. So is everybody with me so far? All right. Now, here's a graphical representation from your book that kind of illustrates some of the concepts that we've had in previous class lectures. You know, last time on Monday, the in-class exercise was proving that you shouldn't pick the item that has the greatest IRR necessarily. You know, when you're comparing two alternatives, the one that has the highest IRR may not be the most profitable. I mean, sometimes it is, but there are situations where, as in this is illustrating, option A has the higher IRR, 17.3 versus 16.3. So option A, if you're going to just look at the IRRs alone, option A looks better. But when you discount at the MAR, then what you find is that the present worth of option B is greater. So the present worth of option B, when you're discounting at 10%, is $10,131. So this would be the profits you get to keep if you were paying 10% interest to borrow the initial cost. And so option B should be selected. Present worth analysis will never let you down in identifying the best alternative. But sometimes we want more information than present worth analysis can give us. Sometimes your boss is going to want to know, if we buy option B, what's the rate of return on the additional amount? And so what's the rate of return on the extra $20,000? So consider this. You've got these two industrial trucks that you're choosing from, and you know that you're going to save some fuel, but the question is the rate of return on the increment greater than the MAR? And the reason why we ask that is you should always do an investment if you're going to make more than the MAR. It's like that example of, if you can go to one bank and borrow money and they're only going to charge you 5%, and you can go deposit it in another bank and they're going to pay you 7%, you get to keep the difference. And so you should take as much money as the first bank will give you and put it into the second bank. You should maximize that investment as long as the rate of return is greater than the MAR. So here in incremental analysis, what we're trying to do is we're trying to find the crossover point between these two alternatives. And this little delta, the triangle, that means the incremental internal rate of return. So the incremental internal rate of return on a graphical basis is the interest rate that would make the present worths equal. And so we're going to go through a procedure today that will tell you, when you have two options that cost a different amount, how you find this incremental internal rate of return. So if 10% is your MAR, we know that you should choose option B because it gives you the most profits. And so the name of your in-class exercise today is Incremental Internal Rate of Return Analysis. An analysis is where we're choosing from among alternatives. We're picking one option versus another. It's a step beyond just applying a method. Analysis is when you're doing decision making. And so in decision making, remember, what we can't do is use the IRR. We can use IRR for initial screening just to tell us if a project's acceptable, but then for the picking which one to do, you should ask, is the additional investment amount yielding more than the MAR? So here it's in bold and italics because it's really important. The increment represents an additional investment amount. All right, so here's an illustration of an incremental analysis, comparing option B and option A. So in this particular case, you'll notice that 10% is the MAR, so that's the minimum, and we can do an IRR analysis, and both of them are acceptable according to the MAR. Both option A and option B are okay, but the question is which one is better. Now, the present worth analysis tells us option B is better because it has the most present worth, but we can also find out that option B is better through analyzing the increment. And so the incremental cost is $13,000 at year 0. Then you have an incremental revenue of $4,225 for 4 years. And if you discount this to the present at the MAR, so we're finding the present worth of this whole increment, discounting at the MAR, then the leftover is $393. And since that's positive, then that tells you, yes, choose option B. And another way that also verifies option B is the selection is because the incremental internal rate of return is greater than the MAR. And so the decision criteria, I'm going to write it here on the whiteboard. Decision criteria, if the delta IRR is greater than the MAR, then select the more expensive alternative. So what that means is you're going to be making more than the minimum on the extra amount that the more expensive option costs. And so you should choose the more expensive option. So here we choose option B. And we know to choose option B because the present worth is the highest. And when we look on an incremental basis, we know to choose option B is that when we find the present worth of the increment, discounting at the MAR, the present worth is positive. So that's another way to know choose option B. But the focus of our analysis today in class is looking at the incremental internal rate of return. So both of these are just regular internal rates of return. But this 11.4 is an incremental internal rate of return because we're doing the IRR function on the difference, on the increment, in other words. Now, the letter I has been thrown around a lot this semester in your book and in the lecture notes. And so let's just review the different meanings of the letter I. So first thing that we did in the semester, capital I meant an interest amount. And of course, we know that interest amount is what's paid to account for the time value of money. And so If we want to express that as a percentage of the original amount that was loaned, then lowercase I is the interest rate. So uppercase I is interest amount, lowercase I is interest rate. I star means the rate of return. And rate of return is an interest rate that brings the inflows and the outflows to equilibrium. So it means that there's a zero balance after the final payment. Internal rate of return is a special case of this where you're assuming that all the earnings can be reinvested back into the project. So a food truck, for example, isn't able to receive reinvested earnings because once you've bought the food truck, you can't take the day's receipts and buy the food truck again. Whereas, by contrast, a savings account, you can leave the money in the savings account and the interest continues to compound. Okay, I prime is the external rate of return, and that's the one where the funds cannot be reinvested, like the rare painting, and it's a weighted average that takes into account the rate at which profits are generated and then also the rate of return that's external to the project, the external reinvestment rate. And that's I sub I, external reinvestment rate. That's a component of I prime. Now finally, delta I star is the incremental rate of return. So it's the rate of return on the extra investment required for the more expensive option. That's what we're going to be solving for today, is delta I star. All these definitions are in the slides if you didn't get a chance to copy it down quickly. All right, so let's compare more than just two options. Let's say that we've got, in this case, 5 alternatives and we're trying to figure out which one is best. Okay, so option A, B, C, D, E. The way that you do this method is, first of all, you sort them, starting with the smallest and going through the largest. So if the data that's given to you isn't already in that order, then rearrange the columns. It's just easier than trying to remember which was highest and which was lowest. So rearrange the data so that it starts with the least cost and increases from there. Now, the first thing we want to do is just an initial screening. Remember, the IRR will tell us if there's any that we should reject outright. And so that's the first step, and the decision for the IRR analysis is that they're all acceptable because the IRR is greater than the MAR of 18%, so all of these are okay. We won't lose money doing any of these projects. But the question is, which one is the best? Which is the best alternative? Should we do the cheapest one? Should we do the most expensive one? So the way that you do this is you start with the cheapest. You assume that the cheapest option is your first, it's your first choice, and you're going to compare everything sequentially starting with that. So compare B versus A, because B is the next most expensive compared to your current champion, which is option A. So the difference of B versus A is an extra $12,000. So you see that in year 0, the increment is $12,000, and then the incremental revenue is B is earning an extra $3,100 in each period. So spreadsheets make this so much easier than trying to solve by hand. So down here, we just do the IRR function, and the IRR function on the increment tells us 22% is the rate of return on the increment. And so the interpretation then is that the more expensive option is justified. So A was our original preference. Now we've switched to B. So the decision is, since the delta IRR of 22% is greater than the MAR of 18%, then we accept B. So now our next comparison isn't C versus A, because we've already rejected A. So once you've rejected an option, you no longer consider it. B is our current champion, and so we're going to compare C to B. So you can see that's the next incremental column. So it's an extra $5,000 in the initial cost. You can see the incremental revenue is $2,200. Now the rate of return on that increment is 43%, and that's beautiful. So we definitely want to accept that since it's greater than the MAR, accept C, and now C is our preference. Now our next comparison will be C versus whatever's more expensive than that. So D versus C, and you'll see the incremental cost, the incremental revenue. That works out to internal rate of return on the increment is 0. So what that tells us is that we have to reject D because it's not justified to spend the extra $5,000. You're earning 0 rate of return. So you wouldn't like option D, and we reject D and we keep C because it was less than the MAR. And now the last lesson to learn here is that we still have one more alternative to consider. We have to look at option E. Now we're not going to compare E and D because D's already been rejected. We already know D's a no-go. So we're going to compare E to whatever was the most recent champion, and that was option C. And so E versus C, do the incremental analysis, and 14%, that's wrong, isn't it? That's less than the MAR. I don't know why I say that's more than the MAR. 14% is less than 18%. Boy, I'm surprised that it's the first time I've noticed that. So I need to fix that because what we do is say less than the MAR, reject E, and keep C because our MAR is 18%. If it's only yielding 14, then that's not good enough. So the key lessons to keep in mind is that, I'll clean that up in just a bit. The key lessons to keep in mind is sort it from cheapest to more expensive. Start with your initial screening to see if any of them can be eliminated straight away. And then do the IRR function on the increments. And when you've eliminated one, then move to the next. And so that's why we didn't do E versus D, is because D was eliminated. So our last comparison was E versus C. All right. One other note. If, here these were A, B, C, D, E because there was no other name for the option. But if the option does have a name, then rather than using A, B, C, D, then maybe just use the name of the option or an abbreviation for it. So, for instance, in today's in-class exercise, you're comparing Caterpillar, Komatsu, Volvo, Hitachi. Don't call those A, B, C, D. Maybe call them C, K, V, H, and so on. All right, let me give you the handout, and we'll get started on this incremental analysis. There's some manual things to do here, and then also some things on the computer for the initial screening. What's that? All right, let me grab some more. Here you go. Thanks. Thank you. So in the end, you're going to set it up to look a little bit like this table. Your in-class exercise will look similar to this one, except for you won't make a mistake on your last analysis like I did.
So, in that example, would we accept option C then as the winner or not?
Yep, option C is the winner. Remember, it's pretty important to sort them on the leftmost column is the cheapest, and then order them in increasing amount of cost. Mm-hmm.
And you took the incremental return of this one,
Mm-hmm.
and it's like this one minus this one, and it's over this. Let's say 44% like it was up there.
Mm-hmm.
See how this was like 43%?
Mm-hmm.
And then the next one, when you get like to D minus C, if that was just like 19%,
Mm-hmm.
even though the other percent is higher, you would still take
Yep.
option. You'd still take the option D.
Mm-hmm.
Okay.
Yep. So what you need to do first of all is put them in order of cheapest over here and more expensive. So your first comparison won't be Cat versus Komatsu. So since that's less than the MAR, you can reject K, and you don't have to do the incremental, any comparisons against K, because it can be rejected from the very beginning. So when we do our initial screening, it looks like there's one of the options we can reject from the very beginning, right? Just from the internal rate of return, we can see that Komatsu's no good. The rate of return on Komatsu is 9%, and that's less than our MAR of 12%. So when we do our comparisons, our first one is going to be cat versus deer. Komatsu never gets a second look because its IRR was less than the MAR. So our first analysis is cat versus deer. All right, we've only got 4 minutes left, so I'm going to apply this decision criteria for all of the options that are acceptable. Our initial screening rejected Komatsu, so I don't need to do an incremental analysis on Komatsu because just the absolute IRR analysis told me it's out of the running. My first comparison is cat versus deer, and you see I've got the incremental cost, the incremental revenue, and then when I do the IRR function on that difference, it's less than the MAR. So 11% is less than the required 12, so the interpretation there is it's not worth spending the extra money. So the more expensive option, cat, should be rejected, and deer remains our preference. So then the next comparison is Hitachi versus deer. We're not going to compare Hitachi to cat because both cat and Komatsu have already been rejected. So the comparison is Hitachi versus deer. Incremental cost, incremental benefit, and you can see the rate of return of 19% says accept Hitachi. So now Hitachi is our preference. And so then the next comparison, Hitachi versus Volvo. So Volvo minus Hitachi, we find the incremental cost. The incremental benefit is a paltry $700 per period. That hardly seems worth justifying it, right? In fact, if you multiply 700 times 10, you're only getting 7,000 back. And that's why when you do the incremental rate of return analysis, it's negative. So that tells you reject Volvo, and we're sticking with Hitachi for now. So our final comparison is Atlas versus Hitachi. And so you can't set up all of the columns before you do the analysis. You only know one column at a time which one is going to be included in the comparison. So Atlas versus Hitachi, and let's see what is the rate of return on that one. It's positive, but not high enough. It needed to be 12, and so we reject Atlas. It's not worth spending the extra amount. And then the overall winner is Hitachi. Now let's make sure that's true. The way we can make sure it's true, remember, the one we can always trust is present worth analysis. And so I'm going to find the present worth of all of these options. So it's going to be the initial cost plus the NPV function of anything that's not at the present, where I'm using this MAR as the discount rate. So I'll take years 1 through 10 and take them to the present with the NPV function. And so let me make the precision a little lower so it'll actually show on the screen there. All right, and then I'll drag this sideways. Which one has the highest present worth? It's Hitachi. And so present worth agrees, the incremental analysis agrees, Hitachi is the best alternative. I regret that we had to go through that kind of quickly because this is a really important analysis, and I know that it can be confusing, like what order to do things. So just in conclusion, what we did was we first rejected anything that had the internal rate of return less than the MAR. And so that's why Komatsu was out in the first round, and the first comparison between alternatives was cat versus deer, not Komatsu versus deer. We had already rejected Komatsu, and so every time you reject something, then you move on to the next highest alternative, and what you're always asking is it worth the extra amount? Are you getting a greater return back than the minimum for each more expensive alternative? So Hitachi is best. Okay, so we're out of time. Let's just take one last look at these announcements. Your homework assignment is due on Monday. And if you have questions about the project, please feel free to stop by during my office hours, and I'd be glad to talk to you. Have a good day.